So the last problem from the limits unit of the review, sketch a graph that satisfies all of the given properties and write its equation. Now there are infinitely many different ways you could do this problem. Let's go ahead and try and do it in the simplest way. So let's draw a graph of what we want to happen. The limit as x approaches 3 equals negative infinity. So let's go 1, 2, 3. Let's dash in an asymptote. If I want the limit to equal negative infinity, it means that my graph has to go to negative infinity on both sides, which means it has to be down there and it has to be down there as well. Algebraically, what that means, if I have an equation y, in the bottom of my fraction, I need an x minus 3, and I need it to be squared. That will ensure that the tails go together. It doesn't ensure that they're going to go down, but it will ensure that they're together. So let's look at the next thing. The limit as x approaches negative 2 from the right is positive infinity. So let's go to a negative 2. Let's dash in an asymptote. Make sure it's dashed. Dash it in. There we go. And from the right, we want it to be going to positive infinity. So this needs to be going up like that. So how do we create an asymptote at negative 2? Well, we put a factor of x plus 2 in the bottom there. All right, and again, that does not ensure that it will go up to positive infinity, but it does ensure there's an asymptote there, so we just need to make everything else work as well. Third one, a limit as x approaches 0 exists, but f of 0 does not exist. Easiest way to do that is to just create a factor of x in the top and a factor of x in the bottom. That will ensure that there is a hole at the x value of 0, which means the limit will exist, but the function is undefined there. So finally, the last thing we want is we want the limit as x approaches infinity to be 2, which means I have to have a 2 in the numerator. Let's draw in that 2, and then let's think about what else we need to do to this function to balance things. Okay? If I want this equation to have a horizontal asymptote at 2, I need the degree in the numerator to equal the degree in the denominator. Okay? So what am I going to do? I am going to, first off, I need this branch to kind of come up and connect with that branch. So let's go ahead and cross the x-axis right there. That's a choice I've made, to cross the x-axis there, but by doing so I need to reflect that in my equation. I have an x-intercept there at a positive 1, which means I need a factor of x minus 1 in the top. So I've now crossed there. Let's not forget I had a hole at the x value of 0, so let's put a hole there, and it will continue up to the graph like that. So that middle piece looks pretty good. Let's think about what happens to the right here. I have this branch down here which has to come up and has to approach this horizontal asymptote, which means it has to cross the x-axis at some point. So let's just choose where we want it to cross. We're building this function. We get to choose where it crosses. Let's see, 1, 2, 3, 4, 5, 6. Looks like if we're going to scale, that thing crosses at about positive 6, which means we need a factor of x minus 6 in the top. Alright, so where are we currently? Currently we have 1, 2, 3 powers of x in the top, and we have 1, 2, 3, 4 powers of x in the bottom, which means we need an additional power of x in the top. So I'm going to create an additional power of x in the top by making this tail go down, curve up, and approach that horizontal asymptote, thus creating an x-intercept right there at what's maybe 1, 2, 3, 4, negative 4. So I have an x plus 4 in the top. So now my function totally agrees with my graph, and it satisfies all those limits. As x approaches 3, the limit is negative infinity. As x approaches negative 2 from the right, the limit is positive infinity. As x approaches 0, the function is undefined, but the limit exists because we have a hole. As x approaches positive infinity, I have a horizontal asymptote at positive 2. The function agrees with all of those pieces. My x minus 3 asymptote is squared because my tails are going together. The x plus 2 asymptote has an odd multiplicity because my tails are going apart. I have a power of x in the top and the bottom, creating a hole in my graph. I have an x minus 1, creating an x-intercept that crosses at 1, an x minus 6, creating an x-intercept that crosses at 6, and an x plus 4, creating an x-intercept that crosses at negative 4. And I have a fourth degree function in the top and a fourth degree function in the bottom, which means my horizontal asymptote will occur at my coefficients, which is 2 over 1, so the limit as x approaches infinity is 2, and we are finished. Again, not the only way you could do this, just one possible way. There are infinitely many ways you could have approached this problem.